I want to very quickly talk about an indefinite integral mistake that should be avoided at all costs. I am Mr. Ish. You're joining me for this video and thank you for joining me. Imagine you have an integral which looks like this. You have some ax plus bx dx. You use the properties of integrals for whatever reasons. You separate them out like this, and you know this is a very legitimate property. You separated everything out individually across this positive sign. You do the integral over here, the antiderivative, you get ax squared over 2 and you make a plus c. You do this one, you do bx squared over 2 plus c, and everything here is looking good except for this part right here. You've created a double constant of integration when all you should have really done was create a single constant of integration, and your antiderivative would be ax squared over 2 plus bx squared over 2 plus c. This here is the correct, this right here is wrong. Do not create extra constant of integration simply because you separated your integrals out into multiple different integrals and you're creating a different constant from each. That's not how it works. You have a single variable over here, therefore you must demonstrate only a single constant of integration. You can see this type of situation arising like perhaps in this. Sine square x dx. You use a identity, trigonometric identity, you make it into a half angle formula. 1 minus cosine 2x over 2 dx. You separate everything across as minus. You're looking here at a 1 over 2 dx, and then that minus, then cosine 2x dx, and then of course you have a 1 over 2. But from the antiderivative here, you just have a single constant of integration, not double. You're not going to generate one from here and one from here and you'll have two. You'll still have only one. Keep these specific items here in your mind and do not make this mistake of creating extra constants of integration. One variable here will imply a single constant of integration as a result of that indefinite integral procedure. That's all we're going to talk about here. Thank you.